going to tell you how to know if a molecule in its Fisher projection like this over here is in its R configuration or if it's in its S configuration. And then after that, I'm going to tell you a really cool trick which tells you that if you're given two pairs of molecules and if you're asked how do you know if they're identical or diastereomers or enantiomers of each other, right? So I used to always find these kind of questions to be really confusing, because like, how do you find out if they're enantiomers or identical? So I have this amazing trick, and within seconds you can solve such problems really fast. Alright, so first of all, I'm going to briefly tell you how to find out if a molecule is in its R configuration or S configuration. Alright, number one, number the groups in the order of their priority. And priority proportional to molecular mass. So the more the mass is, the more the priority is. Alright, so over here, hydrogen has the least mass. Hydrogen has number 4. Then carbon, number 3. Oxygen, number 2. Fluorine, number 1. Right, fluorine has the maximum mass. Alright, then we go from 1 to 2 to 3 to 4. We make a spiral from 1 to 2 to 3 to 4. So 1, 2, 3, 4, we go like this. Alright, now this direction in which we've gone is the clockwise direction. This is the clockwise direction. We could also have gone in the anti-clockwise direction. Alright, so whenever you're going in the clockwise direction, it's always R. And whenever you're going in the anti-clockwise direction, it's always S configuration. Now how I learned this, there was a mnemonic I used that whenever you see clockwise, C for clockwise, think of cancer. Cancer, C for clockwise, R for R. And whenever you see anti-clockwise, whenever you see an A, think of AIDS. AIDS. Alright? A for anti-clockwise, S configuration, C for clockwise, R is the R configuration. So we've moved clockwise over here, so we have an R configuration. So you may think that the answer to our question is R. But actually, the answer is not R. The answer is S. Why this happens, this is, a teacher may like trick you, alright, into taking the answer as R because the first option is going to be R and you're like, oh, whoa, let's go for R. But whenever, this is a very important point to note, whenever the hydrogen atom is in the horizontal position, the configuration is swapped from R to S. So whenever hydrogen is in the horizontal position, you swap your configuration. So R goes to S and S goes to R. So if hydrogen was over here right now instead of over here, then my answer would be correct. But now my hydrogen is in the horizontal position, so I'm simply going to do all this work and then I'm going to swap my answer from R to S, so our molecule over here is of the S configuration. Alright, so this was basically naming your molecule, whether it's of the R configuration or whether it's of the S configuration. Now, this was pretty easy, right? Now, I'm going to tell you about my trick. This was this, okay? Now, I'm going to give you another molecule. Let's say over here, I have a CH3, I have an OH, I have an H, and I have an F. Now what the question is going to ask you is that what is the relationship between these two molecules? Are they enantiomers? Are they diastereomers? Are they identical? Alright, so a ground rule here, the trick over here is we're going to talk about interchanges. Interchanges, which also mean swaps. Alright, interchanges mean swaps. So the rule is odd gives you an enantiomer, and even gives you identical. What this? Alright, so you may have seen rules on the internet based on 180-degree rotation or flipping over, but I find those rules to be extremely confusing, so this is a really simple way. What does this actually mean? The main difference between these two molecules is that CH3 is the same and OH is the same. The main difference is that I've swapped these two groups. I've swapped my fluorine and hydrogen. Over here, these two groups are swapped. So I have one swap, and one is odd. So from my trick, I get the result that these two molecules are enantiomers. And let's just check the configuration of this molecule to make sure that I've done this correctly. Alright, fluorine number 1, oxygen 2, carbon 3, hydrogen 4, just like we did in the previous question. Then you go from 1 to 2 to 3 to 4, so 1, 2, 3, 4. So this is clockwise, and because hydrogen is vertical, so I can directly say C is for cancer, C is for clockwise, R. So this molecule is of the R configuration. And this molecule was of the S configuration. And we know that if this is S and this is R, these are enantiomers. Simple. So you didn't actually have to do all this work. You didn't actually have to do all this labeling and twirling it in the same direction. Alright, so it's going to save a lot of time. Now, because my interchange, only these two groups were interchanged, the rest of the molecule was totally the same. CH3, CH3, OH, OH. I had just flipped my F and H. Now let's do an even number of interchanges. Let me interchange this group and this group. So let me put an OH over here and a CH3 over here. Alright, I'm going to erase this that I've done, and I'm going to label these in the direction of their priority. So this is CH3, sorry for my writing, this is OH. Fluorine number 1, oxygen number 2, carbon number 3, hydrogen number 4. Let's go from 1 to 2 to 3 to 4. Now I have this direction. This direction is anti-clockwise. And boom, I get an S. This is S and this is S. So I did 2 interchanges. I did an even number of interchanges. And my molecules are identical. So this trick is totally correct. It always works. So basically all that you've got to do when you get 2 pairs of molecules is just just ask yourself, can I convert this molecule into this molecule in an even number of interchanges or an odd number of interchanges? Swap this interchange number 1, I swap my fluorine and hydrogen, I get this. Interchange number 2, I swap my OH and CH3, I get this. So my number of interchanges is 2, hence my molecules are identical. Hence, if this is S, this is R, if this is S, this is S, and if this is R, this is R. As easy as that. And this is how you find out whether molecules are RNS and whether they're enantiomers or identical. Please give me a thumbs up if you like my video, subscribe to my channel for more and more videos, and write down topics you'd like to be covered in the comment section below. Thanks for watching.